Today we are going to talk about kinetic energy. Let's see what's the kinetic energy, what is the formula of the kinetic, and what is the difference between kinetic and potential energy, and see some examples of them. Now, we said before that the energy is it's the ability to do a work. And to transfer this energy, you need a force by applying a distance. One of the types of the kinetic energy, is kinetic energy. The kinetic energy, it is the energy of a moving object, or it is an energy in motion. So it is an energy of moving object. The potential, it is an energy when the object is at rest. Here, when the object is start moving, or it's moving, or it's in motion. The words of kinetic, it comes from the Greek words kinetics, which means moving. So where's the kinetic comes from? You cannot say, you can't say why we call it not moving energy, because the word of kinetic, it's from kinetikos. This is a Greek word that means motion or moving. Now, what is the formula of the kinetic energy? It is half mv squared, whereas m is the mass and v is the velocity. So here, the kinetic energy, the formula of it is half. This is the mass, and this is the velocity.
Since it's for motion, so of course it will have a velocity. We can memorize it like that.
Exactly. Since we have it start to move, we have a velocity. Now, if we double the mass, the kinetic energy will be doubled. But if we double the velocity, since it's squared, so it will quadruple the kinetic energy. So the doubling the mass will double the kinetic energy, but doubling the speed will quadruple the kinetic energy, because V here is squared. So from here, we will see that the kinetic energy depends on the mass and the velocity. But the potential, it has half mgh, half mgh. So mass and the height, or the vertical distance. So the potential difference, the potential energy depends on the mass and on the height. But here it depends on the mass and the velocity. This is here the definition of the kinetic.
Teacher?
Yes.
Teacher, there's something confused me about the gravitational potential energy. The definition of it, like I know how its definition, it's a vertical height because of the gravitational, but how can I define it? Like, how can I say it in a simple words?
You mean its definition?
Yeah, because its definition in the PowerPoint, it confused me, like as a result of a vertical, as a result of the gravitational attraction. How can I say it in another way?
I will not ask you to write its definition, but just here to understand
it.
A potential of the height. Now, this height is coming from, there's a force, in the force on the earth that's pull the object down. So this pulling the object down, it gives you a vertical height.
Oh, okay. So it's okay just to understand it. No need for revising it.
Okay, I didn't like to memorize in physics. I like to solve, to understand, to explain, but not to اللي هو الحفظ يعني. Okay, not memorize something. Just memorize the words. No, just understand and solve. And I like physics because of you understand and you solve. And that's why I wish that when I was at school, I like to have physics like understanding it. But some of the teachers want us just to memorize.
Yeah, your way is better and easier actually. Like just understand it and then write.
Now let's calculate here some examples of the kinetic energy. A 0.1 kilogram bird is flying at a constant speed of 8 meters per second. What is the bird's kinetic energy? So the bird here is flying, so it's moving. So I want to find the kinetic energy. M and V. I need the mass. I need the mass. Oh my God. I need the mass and I need the speed. So we say that it is half mv squared.
Mass and velocity squared.
So half 0.1 times 8 squared.
No, teacher, it's 0.10 or it's okay.
That's
Okay.
the same. So 64 divided by 8. 64 divided by 2. 32 times 1, it will be 3.2. Now, what is the unit of kinetic energy?
Can I say it's kilogram times mass times meter per
Second, or joule.
Okay.
Because it's an energy. So
yeah,
it would be joule. So here, kinetic energy is half mv squared, half the 0.1 kilogram times 8. So the answer will be 3.2 kilogram meter second or meter square over second square, or 3.2 joule. Let's have another example. Here, a 1000 kilogram car has a velocity of 17 meters per second. What is the car kinetic energy? I need here to find the kinetic energy.
it's equal half times mass times velocity squared.
So half mv squared, yes. Half, the mass
times
here
1000
is 1000, and the
times
velocity 17 squared. So it will be 500 times 17 squared. Wait a minute, please. So it's 0 joule, or we can say that it is 144.5 kilojoule. This is how to find the kinetic energy. Is it easy or is it clear? Do you have any?
Yes, teacher.
Yes.
Teacher, if it was in millions, can I just write megajoule and divide it by 1 million?
It will be 0.14 megajoule.
Okay. Thank you, teacher.
Yeah. Yeah. Another example here.
Oh, teacher, even in this question, I can write it in megajoule.
Yeah, I told you, yes, you can write, yes, you can divide the answer, but if you write it like this, divide it by,
it's easier. Yeah.
it will be like 0.14. You can say it's 1.14 megajoule, but this will be more accurate.
Yes, okay, thank you, teacher.
Okay. Now here, the same questions. 70 kilogram man is walking at a speed of 2. What is his kinetic energy? So from the words, since I say walking, so you have to be now distinguish between potential and kinetic. Since he is walking, so we have a kinetic. So the kinetic energy here is half mv squared, which is half the mass is 70 and the velocity is 2 squared. So we have it as 140 joule. It's very easy one. The answer is 140 joule. Yeah, I want you now to solve number 3, since they are very easy. Here, a 1,400 kilogram car is moving at a speed of 25 meters per second. How much kinetic energy does the car have? I'm waiting your answers. Send it on WhatsApp. Just send the final answer. And I want the answer in kilojoule.
Teacher, send it in the WhatsApp?
No, in chat here. So I want the answer in kilojoule. Okay, thank you, Hanin. Hanin, from where you bring this number?
Which number?
Your answer, I mean.
Oh, I think I forgot to square it. I'm sorry.
Oh, okay. Thank you, Susan, also. Thank you, Habiba. Thank you, Rose. Yara, thank you so much also. Aywa, yes. Now, Hanin, yes, it's correct now. Now, so let's now solve it here. Thank you, Habiba. Thank you. Is Raghat here? Habiba, thank you, Hanian, Rose, and Susan, and Yara. Raghat, are you here?
No, teacher, she's not.
She is in the meeting.
Yes, she's in the meeting here. Raghat?
Teacher,
So here, the kinetic energy is half mv squared. So it is half Muhammad. Sorry, but are you Lana or Lama? Muhammad Ahmed.
I'm Lama.
Thank you, Lama. Thank you so much. So please change your name. So half 1,400 times the mass, which is 25 squared. So 700 times 25 squared, you will get the answer as 437,500. This is in joule. I want the answer in kilojoule, so you have to divide by 1,000. Divide by 1,000 without calculator. Here, the decimal point is here. Since we have 3 zeros, so you have to go 3 digits. So the decimal will be here. So the answer will be 437.5 kilojoule. Now, here, a 50 kilogram cheetah has a kinetic energy of 18,000 joule. How fast is the cheetah running? So here I have the mass, which is 50, and I have the kinetic energy, which is 18,000, and I need to find the velocity. Now, the kinetic energy is half mv squared. To find v, let's multiply here by both sides by 2m. By 2 first, yeah. When you multiply here, you have to say 2 kinetic energy is mass v squared over the mass. So v squared is 2 kinetic energy over the mass under the square root. So from this formula, we can obtain, or we can derive a new formula to find the velocity, which we say the velocity is the square root of 2 kinetic energy over the mass. Or you can use this one, this one here. We can use this one That's I move it now to solve. Then you have to use it. You can use it, substitute, and then find the square root. Or you can use this one. That's what when they are the same. The one that I derive it now, they are the same. How to divide the velocity. So let's here find it by this way. So the velocity here is the square root of 2 times the kinetic energy over the mass, which is 50. So 36,000 over 50 is 720. The square root of the answer will be 26.8 meter per second. This is the velocity here. This is if you want to use this formula, 2ke over the mass under the square root, you will get the velocity as 26.8. Now let's see that I don't want to memorize more formulas. I want to solve it now as half mv squared. I will show you now how did you get the same answer. Yes?
I didn't understand how you get the second formula.
Okay. We say that ke is half mv squared. Okay, so here, divide by half, divide by half. So then, ke over half, that's mean here, it's ke divide by half equals mv squared. Now, if you want to divide anything into a fraction, you have to keep the first one as it is, change the division to multiplication, and write the reciprocal of half, which is 2 over 1. So I have now 2ke is mv squared.
Oh, okay.
Then, after that, I want v only, so I have to divide by mass by mass. So 2ke over the mass is v squared. I want only v, so under the square root. So you will say that the velocity is 2ke over the mass under the square root. You can memorize it. If you don't want, there isn't any problem. You can use the previous formula.
Okay, thank you.
You're welcome. So it's not very important to know it. So here, let's continue now. So let's use now the first formula. ke is half mv squared. ke is 18,000, half the mass v squared. So 18,000 equal 25 v squared over 25 over 25. So v squared is 18,000 over 25, which is 720. Under the square root, you will get that the velocity here is 26.83 meter per second. This is if you want to use this formula, you can also use it and you will get sure the same answer.
Actually, the only difference in solving this problem is just the square root, like because we want to find the velocity. So just square root it and we will find the answer.
This is if you have the velocity, square root the velocity. Yeah, if you have the velocity like the previous one here, you have the velocity. So, or any, so here, the 25, this is the velocity. So square it, multiply it by half of the mass, you will find the kinetic energy. Here, no. Here I give you the kinetic energy, I give you the mass, and you want to find the velocity.
Yeah, and then square it because the velocity is squared.
Yeah, square it. Take it under the square root.
Yeah, this one. Yep. Thank you, teacher.
You're welcome. Now let's see here what is the difference, or let's take some examples of the potential and kinetic energy. Just 1 minute. My kids are
No, teacher, it's
No,
okay.
teacher, it's okay.
okay. So let's now here have some examples of the potential and kinetic energy. Here, as you see, the first one, we have the potential here. Just 1 minute, please. Here, this is the potential. This is the ball. It is at rest before throwing it. This is a potential energy. But once you start, or you push the ball down, it start moving. So it is
And
we have kinetic.
start doing work also. Yeah.
Now, look at the second picture here. We have the ball. The ball here, it's hanging, so it doesn't move, it's at rest, so only we have potential energy. Once you lift the ball is going down, so it starts moving, so we have a kinetic energy. This is a difference between potential and kinetic as a pictures here. Now, let's see here what is the difference between the kinetic and the potential energy. Now, the kinetic energy is the kind of energy present in a body due to the property of its motion. It is because the body is moving. But the potential energy is the type of energy present in a body due to the property of its state. So the kinetic energy is due to the property when it's in the property of its motion, and the potential energy is due to the property of its state. The potential energy is an energy at rest, and the kinetic energy is an energy at motion. Now, the kinetic energy, it can be easily transferred from one body to another. But the potential, no, it cannot be transferred. So the potential, it's not transferable, but the kinetic, it can be transferred from one body to another. The kinetic energy depends, the factors that the kinetic energy depends on is the speed or the velocity, or sorry, are the speed or velocity and the mass. So the kinetic energy depends on the mass and the speed, but the potential energy depends on the height and the mass. This is the difference between them. Both of them are mechanical energy. Both of them here, like compare and contrast. Both of them are mechanical energy. Both of them, its unit, or their units, joules, but the kinetic, it is a property of its motion, but the potential, it's a property of its state. The kinetic is transferable, the potential cannot be. The kinetic depends on the mass and the velocity, because as we said before, its formula is half mv squared, But the potential, its formula is half or without half? Without
Yeah,
half.
it's half height. It's half
There's
times
a half?
height. Yeah, it's
Half
half.
mgh.
Yeah.
Okay, so it depends on the mass and the height. This is here the kinetic and the potential. Inshallah, tomorrow we are going to talk about the conservation of moment of energy. We are going also to solve some examples that's we have a kinetic and potential at the same time at the same places, how we solve them.
Oh, and teacher, you'll discuss about the closed system,
Oh,
right?
yes, yeah, I remember that.
Thank you, teacher.
You're welcome. Do you have any question here for the kinetic?
No,
No.
teacher. Thank you.
No, teacher, you're the best.
Yeah, thank you so much.
Have a nice day.
Thank you.